and action. What's up, guys? Today we're taking our first steps into the world of trigonometry. And trigonometry itself is the study of right triangles. So we kind of, here your junior year, you take pre-calc, we kind of renamed it because it has a lot of other elements in it. But the foundation of trig and trigonometry is what happens in right triangles. Right triangles, very special stuff happens. And like I said, today, taking our first steps. So let's see what we got. Our book, a little different than the last book, splits it up into two sections. So this section, actually three sections. The next three sections were all dealt with this in the same section in the last book. So this should be nicer. It kind of spreads it out a little bit for you. And we break it down at first with the tangent ratio. So it's like, what? But don't let all these crazy big words mess with you. The trig ratios, as you can see here in this first paragraph, they're just a way to compare two sides of any right triangle. You know, you always have the hypotenuse, and then you got two legs. And most of the time, the legs are in different sizes. But when you're dealing with triangles that have, like for instance, the picture here, if they have angles that are the same, aside from the right angle, then you know that angle similarity applies. So the same ratio will exist between the legs. Like for instance, in this little picture here, KL and JL. So there's a relationship that exists there for a certain angle. Well, if I just spread this out like that, the new triangle I created, it will have the same relationship between its legs because the angle at J remained the same. And I could keep on going and make a new triangle. Well, this new bottom leg compares to this leg going up and down the same way that the red one would, the same way that the blue one would. So that's all this is really, guys. These are just ways to compare sides of right triangles. And the first one we call the tangent. And hopefully your trig teacher will explain. These words have an actual origin that we're not going to get into in geometry class, but the tangent ratio is called that for a reason. And it's just when you compare the legs of a right triangle. So this whole entire section is just going to be comparing the legs of right triangles. She's got legs, you idiot, like Sebastian said. Little mermaid action for you right there. All right. So our core concept, the tangent ratio. Let's see what we got here, guys. Let ABC be a right triangle, acute angle at A. So watch how this works. So if I'm with respect to A, so it's always going to be one of the acute angles with respect to. The opposite side is the one that's across from angle A, the one it points to. The adjacent side is the word we came up with for the other leg, because it's like next to it, adjacent, side by side. The hypotenuse is always left out for the tangent ratio because you're comparing the legs. The opposite leg to the adjacent leg. And it's a ratio, so that's like a fraction, right? So you're always going to have something over something, a ratio, a fraction, when you compare these two things. All right, so let's take a look at example one. It should make a little more sense. So we want to find the tangent of S. Oh yeah, in case I forget, tangent is abbreviated tan. Opposite will be op, adjacent ADJ, right? So there you go. All right, so the tan of S, let's write it in example one. Well, where is S? Okay, S is this angle. Its opposite side is 80. So let me write this out. When you write these equations, you always start with the abbreviation, tan. You're going to learn a couple more next section. So the tan, we're doing S first. So the tan of S is equal to the opposite side, which is 80, over the adjacent side, which is 18. All right. Now this says typically when you're finding the tangent ratio, you're going to round it to 4 places. So we're just going to throw 80 divided by 18. You can reduce it if you want to 40 over 9, or you could just go straight to 4.4444. So that's rounded to 4 places. All right, now let's switch gears for the second part of this question. Now we're going to find the tan of r. So the tangent of r, so now I'm looking at r as the angle. So let's compare the legs with respect to r. All right, so the opposite is 18, and the adjacent is 80. So they just kind of switch places. So when I go 18 over 80, that gives me 0.225. And one of the weird things that you'll find in the book here, it's kind of like you have to add the 0 to be at 4 places. All right, so there's the tan of R. It's different than S because they just flip places. You're gonna learn so many more things about this stuff. There's something that's called a cotangent that'll flip these. You'll see that the tangent of one angle is the cotangent of its complement. There's so many cool things you're going to get into the rest of your mathematical lives. But I get to be the introducer. Is that a word? So I get to introduce these things to you, so it's kind of cool for me. All right, try that, monitor progress, pause the video, see what's up. All right, welcome back. So let's see what we got here. The tangent of J, the tangent of K. So J is 24 over 32. And K is 32 over 24. So the opposite and adjacent switch places with respect to whatever angle you're dealing with. All right, so there you go. Take it out to 4 decimal places. Whoop, there it is. All right, now the good stuff. And the main reason trigonometry and these trigonometric ratios are so cool is because a situation like this right here. Check this out. This triangle we have. Well, let's see. We can't use Pythagorean theorem to find the value of x because we only know one side. We can't use 30, 60, 90 or 45, 45, 90 rules because we got a 32 right here. So the trig ratios, guys, they alleviate all these issues whenever your angles aren't 30, 60, 45. It's that cool. All right, now we're going to have to use a calculator for this. So if you want to pause the video, get your graphic. All it has to be is a scientific calculator with a sin, cos, tan buttons on it. All right, so let's see here. We're going to set this up the same way we did the last problem, but now we're going to see we have a variable. So let's do it. With the 32, I know the opposite side, and I'm looking for the adjacent side. So you always start out with the word, the abbreviation of the word, so the tan, then the angle, 32, equals the opposite over the adjacent. So now we have an equation. You're missing a variable, so you got to have an equation to solve for it. So the trig ratios give you an equation. You know a 32-degree angle has to have a ratio of sides in a certain relationship. So your calculator will help you get there. All right, so go ahead, take your calculator out. All right, and here we go. The way that we are going to solve this bad boy, first off, let's clean it up. Now you could multiply both sides by x and then divide by 32, but a nice little shortcut you'll learn in physics is what I call the old switcheroo. It just saves a step. It's really just cross multiplying, and so you're multiplying by x and dividing by 10 and 32, but because this is all just one number, it's like just a quantity. So you can take x and switch it with the tan of 32 and save a step from multiplying by x and then dividing by the tangent of 32. That's all you're doing. But a big time saver as you progress in physics and trig, pre-calc, calc, is to do the old Mr. Stan switcheroo. So now once we're at this stage, it's like, oh, okay, well how the heck am I going to solve 11 over tan 32? Well, your calculator is equipped for this. First you want to do is go to mode, All right, so when you hit the mode button, you see what happens here. We got some options. And for angles, we have degrees and we have radians. When you guys take trig again, you'll learn what a radian is. It's a little more precise way to measure angles. And it's actually a big part of your pre-calc class your junior year, talking about radians. But in the geometry class, we stay in degrees. So you'll get whacked out answers if you don't switch your calculator to degrees before you do this. All right? So go ahead and go down to the radian button and go over to degrees and then hit enter from there, or then just go back to your home screen. All right, so now you're in degrees. So watch how cool this is. It's as simple as I got 11 over tan 32. So just type it in. 11 divided by, now here's the 3 magic buttons. We're going to talk about sine and cosine next section. This section we're dealing with tan. So there's tan. It pops up right there for you. 32. And you can close the parentheses. You don't even really have to though. Then hit enter. And it gives you the side of the triangle that you were missing. So 17.6. We want to round to the nearest tenth. So x is 17.6. How cool is that? So now you found the missing side. And you'll get good at kind of predicting what it could be or what it could potentially be. Because if this is a 32, you know there's a 58-degree angle up here. So 58 is bigger than 32. So the side 58 points to will be bigger than the side that 32 points to. So there's all those concepts that we talked about earlier in this year, and they're going to come back to help you now to find missing values of triangles. All right? How fun was that? Hopefully it was a lot of fun. You looked at that probably like, what? Now you know how to do it. All right. Now our special right triangles, man, they're so special because in pre-calc you're gonna just they come up so often. What's called the unit circle, and in calculus you're gonna just talk about these triangles over and over again. So our book recognizes that and is like, let's give them an example to show them what happens with the tangent of 60. So you know in your special right triangles that if this is a 1, this would be a 2, square root of 3. It's always double for the hypotenuse. Then you take this, you multiply it by square root of 3 to get that side. So a tangent of 60, opposite, adjacent. So the tangent of 60 will be something that your pre-calc teacher talks to you about a lot. And you'll have to just know. You won't probably remember it from this year, but at least you're getting familiar with it now. You'll be like, oh yeah, that's the square root of 3 over 1. So if you just put the square root of 3 in your calculator, and you give it 1.7320. All right, so it's the square root of 3, which is about 1.321 if you're going to round it because it's 0.5. All right, so there you go. All right, guys, so again, recognizing if you're dealing with the 30-degree angle, it would be 1 over square root of 3, but you'll get to that later on. All right, so pause it and take a look at what happens for these monitor progress questions. All right, so back again, here we go. All right, there is one on here. Maybe if you got confused, I'm gonna show you number 4. Number 3 was straight up like the one we did. You have tan of 61, opposite is 22, adjacent is x. There's x on the bottom, do the old switcheroo. But now for number 4, look what happened. When you take a look at 56, the opposite was the x and the adjacent was an actual number. So you don't have to switch your root this time. You're solving for x. So all you have to do is multiply both sides by 13. So they cross out here. X equals 13 tangent of 56. Now let me show you this too. This is a nice step saver. Let me clear this out. So when you're at this stage of 13 tan 56, you can just put that all in at once. 13 tan 56. And you can arrive at 19.3 that way. Round to the nearest 10. So keep that in mind. Little step saver there. So there's a perfect example. 2 examples, guys. So x is either going to be on the numerator or like the example in the denominator. So switcheroo if it's the denominator, multiply both sides if it's in the numerator. Now in number 5, you got a little what if. What if they change the numbers to 5 and 5 roots of 3? Well, you guys know that a 60-degree angle, all these 30, 60, 90s are similar. So it doesn't matter. If it's 100, this will be 100 roots of 3, and the hundreds will cross out, and you're left with square root of 3, just like the 5s cross out in this example. All right, so all tan of 60s are always going to be 1.7331. All right, moving along, our last example. And again, I can't preface this enough. Real life problems, real world problems. Whew, so much trigonometry, so much tangent, and the other two ratios we're about to learn. Physics class is just so full of this. This is such an important. Keep this video and the next video for the next couple sections if you guys are taking physics next year, and just watch them, keep them handy. You'll have them forever. Save them somewhere on your computer. There's so many physics students come back to me and ask me for help with these types of problems. So here we go. Let's see. The angle upward is called an angle of elevation. We'll talk more about that later too. But you got a 59-degree angle right here. You want to know how tall the tree is. So that's the opposite side. And the adjacent side is 45. So you got a right triangle and you know the angle measure. That little gun type thing that I have in my class, it's blue on my podium. That's what you raise it up and it tells you the angle. All right. So there are devices that can give you the angle like that. All right, so how are we going to do this? Well, I got opposite adjacent, so I know tangent of 59 equals h over 45. So there's the setup. Now we have a variable in the numerator, so that's a little easier even. So I can just multiply both sides by 45. And again, let me go calculator. So I can just type in 45 tan 56. And there we go. It wants it to round it to the nearest foot. Okay, we can do that. And so we got about let's go. Let's see, 45, 59. Oh, it's 59. My fault, guys. Let me back it up. I put 56 in there. Back it up. Back it up. Threw me off a little bit. Thank you if you caught that sitting at home. You're like, stop, back it up. 45, tan, 59. That's better. And to the nearest foot, h is about 75. All right. So there we go. So watch sometimes, if you're actually performing a type of problem like this, the nearest foot is fine with you. You just say, how tall is that tree? We're going to do something. We're going to cut it down. We're going to blah, 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 put another one in, whatever. So there you go. Just approximate. All right. Pause your video. Try your monitor progress. All right. Here we are again, wrapping things up. Measure in the height of a lamp post. You stand 40 inches from it. You measure the angle of elevation from the ground to the top, 70. So you got your angle. So the tangent of 70, opposite over adjacent, h over 40. So 40 tan, and you multiply both sides by 40. All right, so 40 tan 70, about 110 inches. Nearest inch again. All right, so that wraps up tangent, my friends. Hopefully the assignment on Clever treats you well, and we'll be having some live chats if you have any questions as we progress into the wacky world of trigonometry. Peace.